So great, good morning, everyone. My name is Michal Burdukiewicz, and on behalf of the WhyR Foundation, I have a chance of moderating this bioinformatics panel. With me, are several others bioinformaticians, and I will be very quickly to introduce all of them. But just before we start, please share with us from where are you from in the live chat. And remember that you can always ask us questions on the chat, on the live chat of YouTube, and also on our Foundation Slack. I'm checking both channels, and I will try to weave your question in our discussion. And today with us are our great keynote speaker, Riinu Pius from the University of Edinburgh, senior data scientist. Sorry, I'm getting it always go wrong, Riinu. Data manager or data. Okay, sorry. We have. Okay, yeah, I see. We have Eyrich Jessen from Denmark Technical University in Lyngby, Copenhagen, a great university with a great tradition of bioinformatics. Stefan Rödiger from Brandenburg Technical University in Zemftenberg, a very nice city with great people and great bioinformatics facilities. And because of the COVID situation and the poor internet connection, on phone, we have Gordon Smyth. Gordon, I don't really think I should introduce Gordon besides saying Lima and Edger. Gordon is a very, very, very well-respected scientist in a field who did a lot of work to establish methods for working with high-dimensional data, firstly for microarrays, but right now these methods are also applied in NGS and so on. So I'm very happy to have you all. I was briefly introducing you, but maybe this is a good chance to share a bit about you, your experience, your principal informatics, your area, with what you are working. So Gordon, maybe you will start.
Okay. Sorry to not be a proper internet connection here. My apologies. My internet has worked wonderfully for months, but went down today. My entire bioinformatics group at the WhyR has been working at home, communicating by internet for 6.5 months now. So I don't know. So it's unfortunate that today is decided to go down. Is there something you particularly like me to address, Michal?
Just if you will be able to tell with your audience what your research interests are and with what you are working.
Well, I work in statistical bioinformatics. I work at a medical research institute. Basically we do cancer research, immunological research, infectious diseases, and I'm head of a research division on bioinformatics, which develops bioinformatics methods for genomics data and which collaborates with other labs.
Thank you very much, Gordon. And let's go to Stefan.
So, thanks for having me. I'm here in Eastern Germany, and my background is I'm a pharma biotechnologist. I studied also forensics, and I completed my PhD in theoretical medicine. But now I work in the intersection between bioinformatics, personalized medicine, and device development. So maybe the most common thing between all of them is the fact that we work with a lot of patient data and that we try to make sense of the patient data. That means we develop methods to quantify biomarkers. We develop approaches to convey the message about the results to the public, and I also developed some open source software packages with Michał. We have a collaboration with Leon, who will introduce himself later on. And what I also do, or did more intense in the past, was working on RKWord, which is a graphical user interface for R, lesser known, or at least not really known to anybody, but RKWord is one of my passions for a nice interface for R.
Yeah. RKWord has this unfortunate timing of being published with, I think, version 1.0 3 or 4 months before RStudio. Was it like this, Stefan?
No. The peer-reviewed paper, I'm just say Journal of Statistical Software, and everybody will know what I mean. So The paper was published in 2012, but the software itself is way much older than RStudio. Thomas Friedrichsmeyer is the main driving force behind it, and he came up with the software in 2005, I think. And it even had something like this HTML thingy, which now has something like Shiny. And so he still is a brilliant guy, and he came up with this. But let's not talk about RK-Watt. We are here for bioinformatics.
Yeah. And health data sounds also like much of a Riinu area, yes?
Yes, hi, I'm Riinu Pius. I work at the Centre for Medical Informatics in Edinburgh in Scotland. I also work with patient data, but in terms of bioinformatics and data science, I'm definitely a generalist. If anything, my specialty is data ops, so making sure different parts of data science or medical data science work well together, that there are tests, there's integrations. So that's what I do. But also anything else that lands on my desk, all in a day's work.
And the very last person is Leon. And Leon, please tell us about your specialty.
Yes, hi everyone. First of all, thank you for having me. It's very nice of you to invite me. So I have a background in wet lab molecular biology, and then I sort of fell in love with bioinformatics later on. And currently I'm an assistant professor at the Technical University of Denmark at the section for bioinformatics. My main area of research is within immunological bioinformatics, also known as immunoinformatics, where I work on trying to figure out what determines whether or not molecules in the immune system actually interact. And for that purpose, I use neural networks. Moreover, this whole deep learning field is sort of the bread and butter of what I'm doing. And it's a very an area which is very up in the time right now because of the current situation worldwide. So there's lots to do.
Thank you very much. And going to our first topic. So Leon, immunoinformatics is always associated with a lot of data, because you can do this, you can analyze this antibodies on many levels, including structures, and the structures are always very intensive regarding the volume. So regarding your research, can you work in R on big data, or are you actually working on big data in R with the content of bioinformatics?
So I actually don't have the problem of too large data, because what I'm working on right now is very limited, because the data that I need, long story short, it needs to be very specific, and it can only be generated using this single cell technology. And all of these technologies are currently under development. So the current data that I'm working on is very sparse, which is definitely one of our challenges. And also with respect to trying to map stuff to structures, many of the structures that we need for my specific field of T-cell receptor immunology are also quite limited. So in fact, my problem is the opposite. That currently I'm limited by the amount of data that I have access to, and the fact that single cell technology for single data points is extremely expensive.
I see. So definitely the problem, the R is working here perfectly because the data sizes are not that large. Yes. And Riinu, in your case, we have images, we have we have data from clinicians. So how much of the data volume you are working with? How large they are?
Most of the data is quite small, but sometimes there's more information in small data than big data. However, we do work with big data is usually in SQL databases, and in that case, we get away with just using dplyr, which is where you can kind of write dplyr code in R, but then it gets run in SQL, so you don't need to load the data into R, just the results and stuff. And there are many more powerful packages. Obviously, kind of Sparks and Hadoops are also implemented in R, but we haven't had the need for that. But there's definitely ways to make R work on big data.
See, so you are using the connections with external databases, and basically in R you are working on small subsets of the data.
Yes, but we also, you submit queries directly from Mars, so the query goes off and runs and then gives you the results back and stuff. But you can get pretty big in our memory as well. You know, you can certainly have millions and millions, but if it's past that, then that's when you need to work with connections.
Gordon, long gone are days where microarrays were big data, and we are still.
Yes, I remember that.
Yeah.
Yes.
Yeah. So tell me, because you have first-handedly have this experience in R of having a large data set in R and R extending slowly its capabilities to handle large data. How do you feel? Were you always comfortable with working with R and your data?
Well, we've always managed with R. Yes, I remember more than 20 years ago when I couldn't plot data from one microarray because I didn't have enough memory on my computer. But nowadays I mostly work with RNA-seq and with ChIP-seq and cut and tag, high-C sequencing technologies. Look, I'm currently working on a project where we're working with 500,000. That's 500,000 single cells. So that's a data set of 10 to the 10 counts. And of course, it's much larger in terms of raw sequence data. So it would be about 10 terabytes. But we don't have a basic problem with R because we use for the sequence aligner. For the read alignment, we use aligners written in C, and then at the end get out read counts or something similar, and then process the data in pieces. So it's certainly manageable in R.
And Stefan, on your side, you are still working with a lot of image data. So how are you working with this in R? Are you working with this in R directly, or you are switching to other solutions?
So the thing is, we started with the question about big data. And I mean, you will always have this discussion, what is big data, what is not big data. So I say file size is not the matter. It's about these four V's that we have: velocity, volume, variety, veracity, and so on. You know what I mean? And that's definitely the thing that we have in the lab. And we come across all this typical stuff that we have to deal with, data preparation. So this veracity, I don't know if I pronounce it correctly, but I guess you know what I mean. So the quality of the data. And theirs are perfect. And regarding image analysis, as a matter of fact, we use R for that. For testing, we use Python. We use R with Python via the corresponding tools. But most of the image analysis softwares I know, like the Imager package, which is really an awesome package from R, is based on C++, and it's really as fast as you can think, and there's no need to worry about speed in this context. And I want to just mention that there was recently, again, at least a few posts on R bloggers about speed and R and size limitations and so on. We must say in most cases, it's based on the fact that many people are not educated enough about the programming language, and they are not educated enough about certain packages. So take, for example, reading CSV files, you can speed it up massively by using the fread package, or you can make it a slow duck by using just the normal R function. And the same applies to using loops versus reliably and so on. You know what I mean. So I think speed and size is a matter of training and education, how good your instructors were, who taught you R, and the pioneers. And at this point, I want to thank Gordon Smyth in particular, because we cannot emphasize enough how influential his work and the works of Robert Gentleman and all the other people were. So if I would be able to applause loudly, I would do this right now, because one of my students doing his bachelor thesis is now using EdgeR, and we are happy to use it.
Gordon, I must admit, I'm very happy that, but it was obvious that we'll find here a lot of big fans of your work. So just a second before we delve deeper into the topic of big data in R. We all know that the HR dilemma are part of the Bioconductor. So would you mind sharing with us a bit about why did you decide to join Bioconductor? Why you weren't with the current guys? What was the design decision behind it?
Well, Bioconductor. I was invited into Bioconductor by Robert Gentleman about 20 years ago, but basically. We develop our packages, so the two major repositories to put them on would be either CRAN or Bioconductor, and Bioconductor is the main repository for statistical bioinformatics for genomic packages. So so Bioconductor offers an enormous ecosystem of related and cooperating packages. For genomic analysis, so it's a natural place to go. It's also a good place to make your packages visible and usable by others.
You mentioned a large ecosystem, and I fully agree with that. The ecosystem of Bioconductor is enormous. And the amount of internal standards of Bioconductor is also very, very. I mean, at least for me, overwhelming. So
yeah. Well, one of the key concepts of Bioconductor, which was pushed by Robert Gentleman initially, but it goes back before that possibly to Terry Speed's group, is the idea of a data class, of creating a data class and manipulating data in terms of a purpose-designed class instead of simply in terms of our primitive objects, so that you can manipulate, say samples and genes together and not lose track of what goes with what.
Yep. So I'm asking other bioinformaticians here. Are you using Bioconductor tools? Are you when you are writing? Are you trying to be in concordance with the Bioconductor standards? How is with you, Riinu?
I don't personally do genomics research, but I know that some of my team members do use Bioconductor packages, and I think it's a great ecosystem. Most of the because we do patient data science without so much genomics, the tidyverse really is the way to go for that. And our packages conform to the tidyverse principles and match with the tidyverse and work together with the tidyverse packages.
Yeah, thank you. There's actually, can I jump in there with something? Sorry. Yep.
Listening to you, Gordon.
I just wanted to say that R is I've been using R since the very first year it was created, which is about 1995 or 1996. But there's sort of almost three languages now. There's base R with the base packages. There's a tidyverse, and there's Bioconductor S4, and they all work together, but they're, from a user point of view, they're almost getting to the point of being partially different languages.
I call them dialects. So when I teach my students, and you're right, they're so different, especially for people who are new to R, they look like completely different languages, but I say that they are dialects. It is possible to use them together. It's possible to make them understand each other a little bit, but they can sound and look very different.
Yes, that's a good way to describe it, yeah.
But Gordon, I have to fully agree with you, especially that these dialects differ on both levels of the API, so what user sees, whatever uses, and also the level of implementation. So, for example, Bioconductor is very strictly S4, and we have tidyverse, which is R6 or S3, R6 mostly. So also implementation differs. And Leon, you are a very tidy guy, I must admit, and I appreciate it, because I think bringing the tidyverse to people is a very easy way to introduce them to R. So what's your opinion? So how much are you using Bioconductor in your work? This is the first question, and the second part is for you, if you are using Bioconductor, is it easy to mesh Bioconductor and tidyverse?
Okay, so currently I'm not using Bioconductor. I have been using it before, and it's an amazing project. I'm full of awe. It's really incredible, and it has moved the entire field of genomics data forth. Currently, I'm working on protein sequence data. So mainly, I'm using tidyverse for data manipulation, which I think works absolutely amazingly. And then I'm feeding into the TensorFlow for R, which is my primary tool. I just want to add, with respect to tidyverse, I've recently created the first tidyverse course at my university, R for biodata science, where I really sort of emphasize giving the students a toolbox which they can use immediately. And I really think there's a split between people who are oriented towards developing the packages and people who are oriented towards actually using them. And I think it's important to be able to do both, but also acknowledge that some people are not interested in developing, but they're interested in applying, which I think is perfectly fine. And in that matter, I really think that the tidyverse has moved also the field of bioinformatics forward with this consistency.
Sorry for being, but I just wanted to bring from the YouTube that Michał has a great remark that Bioconductor, tidyverse, and base are something akin to Lisp dialects. So we are still in the same language, but the Lisp dialects really are different, and I think the differences are quite large. So going back to you, Gordon, how much of, and I want to reverse the question of Leon. So to Leon's, how much of the tidyverse is in your current work?
Okay. Well, for me personally, I use base R as far as I can, and I don't personally use tidyverse at all. There's a basic, in fact, I don't even use RStudio. I use plain R, but in the bioinformatics division, most people are using RStudio and R Markdown. Look, there is I'm not a tidyverse expert, but it seems to me that there's a basic incompatibility between tidyverse and the Bioconductor data structures, in that tidyverse requires data sets to be lengthened out as a data frame, whereas the Bioconductor structures have essentially two data frames, or a matrix and a data frame. They start with a matrix and then a data frame connected to the rows and a data frame connected to the columns. So you have annotation for genomic features, and you have annotation for biological samples. And so, of course, I've worked in that framework for 20 years, so I'm familiar with it long before tidyverse even existed. So I have young people at the WhyR trying to persuade me that it's easier to teach tidyverse to new people, but I personally am still programming in base R.
Can I comment to that? It's definitely easier to teach the tidyverse. In the previous, because I don't use Bioconductor because I don't do genomic stuff, but in the previous life I did a lot of geographical data analysis. In the data sets you would put in a GIS and stuff. And you're absolutely right. The tidy format is not for everything. You're not going to wrangle your genomics kind of the formats of the cell rats and whatnot into a tidy data frame. You shouldn't do that. That's sick. And the same with some of the geographical data. They're really good. There's like half a century of formats, efficient geographical formats, how to put geo layers on top of each other, how to do vectors, shapefiles. All of that's been developed, and you shouldn't be using tidyverse for that. You can make quick maps. You can make a good little chloropleth in the tidyverse, but if you're doing something as specialist as that, use the tools for that. So tidyverse really is for relational databases and analyzing data from the relational databases.
I just want to introduce quickly with a brief remark that Michael Lawrence, Michael Love, and Stuart Lee are doing a lot of work with integrating pipes, at least pipes, as from tidyverse into Bioconductor packages. I googled, so I know for the I wouldn't know them.
Yeah.
Ranges and TXA meta.
Yes.
Maybe
Yeah, we actually have. There's actually a postdoc in our division who's working with Michael Lawrence to try to convert some of the genomic tools to a tidyverse interface. So it's happening even within our division.
Awesome. Leon, go on.
Yeah, so I just wanted to add that with respect to the tidyverse versus the base, that for when I'm writing packages that I need to share with other people, I usually keep them strictly base in order to, as much as possible, limit dependencies. And also I think the way of sort of thinking mathematically about doing stuff is much more easy in base R compared to tidyverse. And then I just want to add, I think we should not try to go in the direction where we think about one winner takes it all. It doesn't have to be strictly tidyverse or strictly base or strictly Bioconductor. I think it's important to sort of use the tool that's appropriate for your particular task. So if a certain Bioconductor framework fits your task best, use it. I mean, it's just simply a matter of getting things done. I think that's more important to have in focus than being very strict about just using one type of tool.
And I want to ask Stefan about one thing that Leon mentioned, and is bringing us to the next topic, to the reproducibility, the dependencies. When you are working with bioinformatics data, Stefan, I know that you have your experience with Bioconductor, your experience with tidyverse, and dependency-wise, what do you think about this? What do you think that both of these environments have some introducing some technical issues related to dependencies into your research? How you are dealing with this?
That's a tough one. I mean, dependencies. I often have the impression that there's a dependency hell that I don't see, because most of the time it works quite nicely. But as a matter of fact, I think we already said it. It's first of all a question what you are doing. So, for example, if I make an app that I want to share, or where I want to make sure that it's working for quite some time, I try to introduce as little as possible dependencies to that. And at the beginning, I didn't really pay that much of attention to this, but for example, I try to avoid the tidyverse approach when I have something in development. When I was starting with one of my more recent projects, the PCR Redux package, at the beginning, I started to introduce some of the tidyverse concepts, but then I noticed, let alone building the whole package with continuous integration, so the quality checking, it takes ages to make sure that the software is properly working, and then tiny changes here and there might cause something serve. So I try to keep it as little dependent to something as possible. And I mean, there are many attempts to make things good. I give an example. The Poorman package, I think right now it's a one-man show, tries to make a minimalist implementation of the concepts that you can have from MacroJar, from dplyr and so on, but it doesn't provide at the moment the quality that you would expect from the comparison to the tidyverse software. But as a matter of fact, I like the idea to have as little as possible dependencies because it really makes life way much easier. And regarding reproducibility, I can say I try to make as much as possible from the workload to make things reproducible, but I would claim starting from the operating system and going over to all the other stuff like auxiliary libraries and so on, it's close to impossible to get it really in a convenient way, which means easy setup and easy reproducibility over a long course of time. So I think if people try to reproduce source code within a time frame of 1 year, it's working. But if they try to reproduce it after 5 or 10 years, it's getting more and more complicated. For example, the biggest issue is for me, for example, 32-bit versus 64-bit. I was using, by a recommendation of a person who is right now in this panel, I was using Anaconda because it's the best for data science, for Python. But Anaconda dropped out of a sudden the support for 32-bit, and I was doomed, so to speak. But this is something that is not helping reproducibility, because you cannot reproduce it if you cannot calculate it. That's the point. So keep it simple, stupid. That's my advice.
And Gordon, Lima is with Bioconductor for the long time, Azure also. So I think you needed to make a lot of changes during the maintenance of the package to keep it in accordance with the Bioconductor. And from the point of view of you as a researcher, you are a researcher, not a software developer. So how hard it was to keep up with the evolution of Bioconductor?
Well, it was a lot of work, and particularly in the early days, it was actually quite challenging because Bioconductor was using R tools which were not even documented yet. We have a policy of continuous improvement for Lima and Edgar. So together with answering questions and helping user queries, it takes some time every day, sort of say an hour a day or something of that magnitude and more when we introduce something new. So it's an ongoing exercise. But I have also, like I think was it Stefan who was saying, I also wrote Lima and Edgar to have far fewer dependencies than is normal for Bioconductor packages, and that's made maintenance much easier.
I see. And Riinu, I have the same question. I have the question about reproducibility to you. With a special impact on that in clinical research, you need to be absolutely sure that you are reproducing your result. So how you are ensuring this?
Like Stefan said, I'm so glad when he did say that. It's nearly impossible to be 100% reproducibility thanks to operation systems and things changing, but you can be reproducible in the short term, obviously. And R Markdown has really helped us. We now write all of our papers in R Markdown until we have a really good draft. So it's a single R Markdown document that kind of creates all the figures and text. And then we finalize it kind of in Word, because then you can email it out to people and get like hundreds of comments back, and you know what I mean. Obviously, it's really difficult if you're running big models that kind of sometimes you need to send models off to run on cluster computers and then to get the outputs back and then incorporate into those R Markdown documents. So then you just have to be careful that the process of how data went into that or how results came back from the supercomputer is also documented. You can't always have everything in a self-contained R Markdown document, but we do try as much as possible to contain it in R Markdown.
Okay, and Leon, I know that you are fighting very hard for better science, for good reproducibility standards in science. Please tell us how you are ensuring this with R.
So I agree with both Stefan and Riinu that you can never sort of achieve, at least currently, 100% reproducibility 10, 20 years ahead. It's not possible. But I think that should not be used as an excuse for not trying, at least. So I'm currently sort of I've also tried to push it on Twitter, but basically there's I saw a paper, I remember when I finished my PhD, which I really wish that I had seen before I started my PhD, about how do you put down a basic structure on organizing your projects, how to create directories, how to link the files, and so on and so forth. And I've sort of I've arrived at a sort of a version of that which I'm myself using and also teaching to my students. So basically organizing your analysis in a way where you can rerun everything without having to interfere in any way, without having to set any temporary variables or parameters or anything, but literally push a button and everything is created. If you can do that, then at least you're a good step in the right direction towards reproducibility. And
thank you very much. And I want to just mention that recent packages. Okay, Drake by Will Nadal is quite along with R, but for example, Renv as a replacement of Packrat, these packages really help to make my R research more reproducible. I was always trying to stick as much as possible to the base R because the other packages are just changing so fast. And of course, you can post R session, but what's the benefit of this? Very little. And finally, I think Renv is doing the versioning of the packages correctly. So I'm very happy that that was the case. And also, I was very happy that the Bioconductor was really keeping, had always this bio installer, which was taking care about the current version of Bioconductor packages. It was also one of the things that I treasured in that I still treasure in Bioconductor. So,
could I say something else about reproducibility?
Surely.
If there's a chance.
Go on.
Hi. Look, my lab has a policy of, I have a lab policy of reproducible reports, which is when we do an analysis for a collaborator, we don't just give them a set of results and pictures, we give them the entire, it's either a PDF or an HTML output, which is from Knitr or Smyth or R Markdown. So it's a reproducible report. So we always know that we can rerun it and easily modify it, and that all the code is included and documented. I've never been too worried though that the same code will not necessarily work with a future version of R or Bioconductor, because to me, what's important is to document what we did. So we store the PDF document or the HTML document documenting what our analysis was to lead to each publication or to each published result, and then we can go back to that as a fixed document without having to rerun it through R. So even if we couldn't rerun that code 5 years later, we can still document what we did, which is, from a medical research point of view, what we need to do.
Thank you very much, Gordon. This reproducible report is and preserving why you did something, and it's certainly a good step in the reproducibility. And for the very end of our panel, because we have only 4 minutes left, Salim Reza has asked a very provocative question on chat. Why not Python? I want to expand on this. There is a very, very large and active community of BioPython, which is contributing really great tools for whole bioinformatics. Starting and I think Python is to go to for example, visualize proteins, visualize structures of biological molecules. So yeah, why are you using mostly R, Riinu?
For the kind of data I'm working on with and the kind of outputs I'm interested in, R is the best tool for the job. However, I would never only use a single tool. I actually use a huge range of tools. SQL I use. I used to do a lot of Python. These days, I find that everything my job requires is in R. A few years ago, I was using 3 different programming languages on a daily basis, just because they all had their own strengths, and you would do the results in this one, then pull it into the next one, and then kind of finish off, depending on the data types that might be necessary. So I would definitely not exclude any Python or any other programming language from potentially being in my toolbox. Lots of things in my toolbox. But most of the stuff I get done with R.
So Riinu, but you know, actually the question is not about why not Python, because I think we all love Python. The question is here, why R? So Leo, your turn.
Okay, so for me, I think it's a matter of. So first of all, I always say life's too short for language wars. I really believe that very strongly. I think again, it's a matter of choosing whichever language one solves your task and suits the way that you're thinking. So Python actually requires a certain way of thinking programmatically, and R another way, and C++ a third. And depending on how you think, they have strengths and weaknesses. With respect to why I am using R, I think for applied iterative data analysis with a lot of visualization, you're constantly plotting and iterating over different ways of trying to get insights into the data. R works really well for me, and I think the whole ggplot sphere is working extremely well. I must admit that currently I'm using TensorFlow in R, but I will also happily admit that I am having some issues when I find error mistakes, because it has to go all the way through the stacks from R and then the Python and then down to C++ and then back again up to me, and then I have to figure out what was going on where. That's a bit challenging, I must admit. So I've actually recently kind of think of maybe I should switch to do that in Python, and then, as Riinu says, then take it into R once I sort of want to work on with that. And just want to add quickly here that I really like the idea about the Wes McKinney Hadley Wickham mindset of trying to work towards sort of language agnostic data science. So you can basically choose whichever language you want, and then you can just interweave them in whichever way you want. For example, if you dump a model from TensorFlow, you can read it into to Python and vice versa.
And how about you, Stefan?
So every now and then I use reticulate, but it's a rare thing. But the question is, why R over Python? I mean, everybody who used Python and R in a project will notice that an R installation is pretty much simple, straightforward. You just install base R, and after that you use, I, for example, prefer remotes to install everything from GitHub, Bioconductor, and so on. So remotes is a great package, and that's basically it. If you work with Python, I don't know how often I encounter the problem that it tells me, please, to fix this problem, please set up a new environment for your Python project. And then everybody says, yeah, just do a new Python environment or do a new Python project. And I never do this with R. It's just like not a thing that happens. Regarding plots and so on, I think there is Seaborn and all the other great packages which are pretty much similar. There are also these concepts that I use in Python, which mimic the pipes quite well. But again, when it comes to statistics, pure statistics, I mean, it's more likely that you get a decent working package that does something for you than you in R than in Python. So just to give you an example, my students were doing with Python in the last semester a project in the field of personalized medicine, and they also have to use either R or Python. And since they had in the year before R, some of them, I said to make them all equal, they had to use Python all. And there was a simple test. What was it? Tokay's honest significance test, multiple comparison issue. To get some reasonable good results with Python was work getting this with R was fun. So that was the point. Sometimes R is just faster and more convenient to work with.
Okay, and I specifically left you for this question, Gordon, to the very end, because you share with R, with Bioconductor, 22 years of history. So tell us, why R?
Well, I would say that R is a much richer environment for statistical analysis. For our division, for our bioinformatics division, the researchers who tend to work with sequence analysis tend to use Python, whereas the statisticians and the statistical bioinformaticians and the transcriptomic analysts tend to use R. So that's the split. Sequence analysis versus statistics is Python versus R. But again, it's but I would agree with the comments made by others that you sort of specialize in a language, and if you become a real expert in one of the languages, you can do most things.
I see. So I just want to mention why I like R, and I must admit, R is awesome. This is language that's really that I feel really comfortable writing in. I don't know why, maybe because that's the only thing that I'm competent in. But still, I really love our community, and I must admit the people from the R community, the user conferences, but also the people from the great folks from our ladies, our forwards. They are really pushing this data science thing forward, and all this thing related to the social aspect of being part of writing in R are really important for me. So that's something that I appreciate in
you have this in Python too. You know this, right?
I know, but I think on a bit different scale, with the bit different accents. But I know that Python has a great community. Okay. Once again, this is unfortunately our time. So it was a very nice 47 minutes of bioinformatics panel. Thank you very much for joining us. Thank you. I especially thank to Leon and Gordon, who had quite hard COVID situation in their countries right now. But I know that the crisis is affecting all of us. Thank you very much for being here, and thank you very much for talking to our audience. And I hope you will have a good day in R or Python. Doesn't matter at the very end. Thank you very much.
Okay.
Thank you for having us.
Thank you. Thanks for the invitation. Thanks for organizing.